Hello, this is Mr. Stansbury. I'm going to take you through the notes on transformations of graphs. At the end of this, you should be able to say I can translate and dilate various graphs. Okay, so first thing, this is our general formula here. Okay, y equals a times x minus b plus c. The a is the dilation. Okay, this is how much it's stretched vertically or squished vertically. That's what the a does. And then also if it's negative in front here, it actually flips the whole graph upside down. So it's reflected in the x-axis. Okay? So if the a here, absolute value of a, is greater than 1, then it gets stretched vertically. So it gets bigger, basically. Okay? And we'll take a look at some of these. And then if the absolute value of a is absolute value of a is less than 1, then it's squished vertically. It gets smaller. Okay? B, this x minus b, this is the horizontal translation. This is how far it moves left or right. Okay? And then c is the vertical translation, how far up or down it moves. Okay? So let's take a look at some examples here. All right, so we have this here, example 10, draw the translation of y equals f of x. So we're saying that this is y equals f of x. So this is y equals f of x plus 3. Okay, so this here, if it's outside of the regular old f of x, if it's just like a plus or a minus, something like that, this is going to mean up or down. Since this is positive, this is up 3. Since this is negative, it is down 1. Okay, so basically if we're going to move this whole thing up 3, just find some key points, and then away we go. So this is at negative 1, 2, 3, 0. So we're going to go negative 1, 2, 3, and it's at 0. But now we're going to move everything up 3, so up 3. So now this point has translated to that point. This is 2 to the left, down 3. So 2 to the left, instead of going down 3, we go down 3, but then we got to go back up. So it's right there. And that goes straight over to here. And then this point right here is over 4 at 0. So we're going to go over 4, but now we've translated up 3, so it's going to look like that. So basically, roughly, this graph is going to look like this. Okay, that whole thing just got translated, just moves up 3. Okay, so same thing here. The whole thing's just going to move down from this here. So now we're down here. This is going to be here, here, and here. Those are all the same little points that we did use for the other ones. All right, so it looks like that, that, and that. Okay. All right, let's take a look at some more examples here. So draw the dilations of y equals f of x. So now we have y equals 2 times f of x. Okay, so this 2 here means that everything's going to get stretched from the x-axis. It's going to go up twice as far and down twice as far. So let's say this point here is at is right here. From the x-axis, it's up 2. So now since this is a 2 here, it now gets doubled. So instead of just going up 2, now it goes up 4. And then this point over here to the left 1, 2 goes down 2. So instead of going down 2, we're going to double that. So now it goes down 4. The 0 stays right there at the same spot because 0 doubled is still 0. And when we go to the right 2, it's supposed to go up 1. So now we go to the right 2, we double that. So now it's going to be up 2 and it comes back down here. So we've kind of, again, made ourselves some little points here to make this work nicely. So we got that, and then we got that, and then this thing's going to curve up and around and come down like that. So this 2 here stretches this whole graph here, stretches it vertically. Okay, so it gets twice as high and twice as low from the x. Okay, now the y equals f of 3x. That's a little different when it's inside the x, inside with the x instead of outside in front of the f of x. Then what happens is this is getting going 3 times as fast basically. So it's getting squished this way. It's getting squished horizontally. So this here stretches it vertically. This one here squishes it horizontally. Okay, so the way to look at this here is, let's see, just to make this a little bit nicer, I'm going to just turn this into a 2 here. It's just going to make our life, with all these numbers here, it's just going to make it a lot easier to do. So let's keep this simple for now. Okay, so originally this is over 4 and up 2. So it's still going to be up 2, but instead of over 4, now we're going, it's going half as far as that. So now we're going to go over 2, up 2. Okay, so it's almost like you've got like a 1/2, a 1 over the top of whatever number's in there, and that's where it's going to be. Okay, so I'm going to put a little hint up here. It's in front of the f of x. That's what you're going to multiply the y's by. And then if it's in with the x, the f of 2x, now you're going to divide the x values by that. Okay, so again, we took our x value, which originally over here was 4, 2. So now we take that 4 and divide it by 2. Now it's only 2, but the y stays the same. It's still 2. Why did I go up there? I don't know. It should be down. Oh, it's because it's this one here. Okay, and this is to the left 2, down 2. So now we're going to do half of the x. So we take 2 divided by 2, and that's going to be 1 and -2. So we go 1, -2 like this. This is, the zeros are going to stay the same there. And then instead of to the right 2 up 1, we're going to go the right 1 up 1. And then this one is to the right 4. So now we're going to do 4 divided by 2 is 2. So it's to the right 2. So now it's going to look, this one here is going to look like this. Okay, so again, this 2 here just made it go twice as fast. All right. Okay, one last one to look at here, but before we do that, let's take a quick little comedy break. All right. Okay, these here, using the graph of y equals f of x, draw the graphs of y equals negative f of x and y equals f of negative x. Okay. Okay, so the negative f of x, the negative out front, means it's going to flip the whole thing over the y-axis. So we're originally at 2, positive 2, so now we're going to go, sorry, -2, positive 2, but now since it's flipped over the x-axis, now we're going to go down 2 instead. Okay, so this here stays at the same spot because you flip that over the x-axis and it's still 0. This was at 1, 2, so now it's at 1, -2. And then this is at, what, 3, -2 originally, so now it's going to be 3, positive 2. And then back to 0, 0. And then we just draw that. Draw these, connect the dots, right? So this whole thing here gets flipped over the x-axis, and here's our x-axis, so it just gets mirror imaged over that, and we end up with this. Okay, y equals f of negative x. When the negative is on the inside with the x, now it actually gets flipped over the y-axis. Okay, and the nice thing about all these, if you ever get confused, is like, which one is it going to flip over? All you do is put a couple of values in make yourself a little t-chart here, and put a couple values in, and you'll figure out exactly which one it's going to reflect over. Okay, so let's see. So now this was -2, positive 2. So now it's going to flip over the x-axis. So now it's going to be over here at positive 2, 2. So positive 2, 2 is that first spot there. And then that is to the left 1, so now it's going to be to the right 1. That's going to be to the right 1 and up 2, so now it's going to be the left 1 and up 2. And that is to the right 2, down 2, so now left 2, down 2. And instead of being to the right 3, it's going to be to the left 3. And then now we can draw our new graph that has been now reflected over the y-axis. Okay? Okay. That's all we have for transformations of graphs. If you have any further questions, please feel free to ask. Thanks.